Hey, dude.
Hey, man. Why'd you pull a no-show for my gig tonight?
Sorry, dude. I have to study for this project.
Studying? Pfft. Looks like you're watching a movie to me, brosif.
It's not a movie. It's a documentary.
Oh. What's it about?
It's about the 400-year evolution of the telescope. I have to learn about the 5 different types.
5 different types? I thought there was just the one that made faraway things look bigger.
Well, you thought wrong. Each different type is useful for different things.
Oh, like a microscope. Makes tiny things seem bigger.
No.
I swear that's what they do.
Yeah, that's what it does, but I'm saying that a microscope isn't the kind of scope I'm talking about.
Hey, is a stethoscope one of them?
No, that's the one you have around your neck.
Oh yeah. How about a gyroscope? Periscope! That's gotta be one.
Seriously, dude?
Scope. 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 Scope.
Not mouthwash.
Well then, what kind are you talking about?
Well, to start with, there are refracting telescopes. They're also called reflecting telescopes for those that have more mirrors in them. The way it works is that there is an objective lens and an eyepiece that when combined allow more light into the eye than is normally admitted. Depending on the eyepiece, the results may vary. The eyepiece then focuses the view and presents it brighter, clearer, and magnified.
So what is that kind good for?
In its smallest form, it could be used for binoculars or a spyglass, but in its larger form, stargazing at an observatory.
Spyglass! Like a pirate, right? Very cool. So, what else is there besides that?
Well, there are telescopes that are sensitive to radiation, like the radio telescope.
Whoa! Does that make music sound closer?
Not even.
This telescope uses a directional radio antenna for radio astronomy. The antennas are used in tracking and collecting sound waves not originated on Earth. They operate in the radio frequency portion of the electromagnetic spectrum.
What is this electromagnetic spectrum you talk of?
It's the range of all possible frequencies of electromagnetic radiation.
What? English, bro.
It shows how much radioactivity is emitted from different things. The telescope needs different filters to view them. Kind of like infrared.
And that is?
Actually, that happens to be one of the telescopes I'm studying.
The infrared telescope uses infrared light to detect celestial bodies. Infrared is found up higher on the electromagnetic spectrum, which allows other galaxies to be visible because of the radiation it projects.
Radical! Are there any other cool radioactive telescopes?
As a matter of fact, yes.
Further up the spectrum, there is ultraviolet, which is also its own type of telescope. Ultraviolet telescopes do practically the same thing infrared telescopes do, only at a higher power. Some of the hottest and energetic stars in the universe are only visible with ultraviolet. Unlike infrared telescopes, however, ultraviolet telescopes need to be in space for them to work appropriately. This is because Earth's atmosphere blocks most of the necessary light.
That's 4. You said there was 5. What's left?
The most radioactive telescope.
The X-ray telescope. Awesome! Can you, see through people's clothes? Can you see their bones?
No.
X-ray telescopes collect X-ray images that are produced from the Sun, other stars, and supernovas by using a series of curved lenses and an electronic eye. X-ray telescopes allow researchers to obtain information on changes in patterns of nearby galaxies. With this information, we now know that the growth of the universe is not slowing, but is in fact speeding up.
This is all very interesting, but I have one important question. Which one of your fancy telescopes is best for looking at hotties at the beach?